So here we have a table with decimal, binary, and hexadecimal. You can see the representation of this, and you can translate from decimal to hexadecimal with the table, but you need to learn to do it also by yourself, and we will show it in the next video. So decimal to binary, we have here a table with the base exponent that we have from 2 to the power of 0 until 2 to the power of 7. This is just for example, but if you continue, then you will have 2 to the power of 8, 9, 10, etc. So we have the value for each representation of base 2 in decimal, and then we have the example of the number 35 binary. So you represent it with 1 1 0 0 0 1 0 0, and then you will take only those that are ones. We take the value of decimal and you will make a sum. So 35 is the sum of 32, which is 2 to the power of 5 plus 2 to the power 1 plus 2 to the power 0. So if we go this to decimal, then we have 32 plus 2 plus 1. This is 3 plus 32, it will be 35. So this is how you can do it from binary to decimal. Then here, if you want to translate from decimal to binary, you can use the same approach here on the left with the table, or you can use the right one. So you take the decimal number and you divide it by 2. And you can see here, for example, 2 divided by 2 is equal 1, and we have residual of 0. So 2 is defined as 1 0, and you have to read the number with the proper way. So in the proper way, you can see here we have the arrow. So the arrow is telling us how to read the number. So here we have the representation and the value is 1 0. And if we go to the table, we can see that 1 is equal to 2. So let's go to next example. It's 15 divided by 2. We have 7, 7, 14. We have 1. Then you continue and then you read your number 1 1 1 1. Then 1 1 1 1. And you can do the exercise backwards. So 1 will be 8. Then another one here will be 4 12. Then we have another one here 14, another one here 15. So the sum of these will be 15. So this is a longer one. You can read and practice this with some examples in your notebook if you want.